So welcome everyone today to the webinar Environmental Interdependencies Matrix for Aviation. Today we are joined by Piero Di Stefano. Piero's principal consultant as part of Noise Consultants Limited, working on noise and assisting the coordination of wider environmental topic areas such as carbon, air quality, and environmental strategy for aviation projects. In today's webinar, Piero will explain the process he helped develop at Noise Consultants to describe the interrelations between carbon and noise emissions for airspace management. Thank you for logging in today, and I'll just hand over to Piero.
Thank you, Derek, and thank you to the IES, Adam Donnan, to invite me to present this presentation, this process that we developed. So this environmental interdependencies matrix for aviation that we use to correlate and understand better interdependencies such as noise, carbon, air quality. So today's webinar, I'll go through just a bit of what I do for work in my role as noise consultant, an introduction of what is aircraft noise and what are the effects of aircraft noise, and then we're going to go through the environmental interdependencies matrix for aviation and what they mean in terms of sustainable development and generally sustainability. So, as Derek already said, I work for Noise Consultants Limited as a principal consultant. I've got 10 years experience spanning from transportation noise and vibration, and in particular, my work is focused on aviation noise. But in the past, I worked on railways and underground train noise and vibration assessments. And at the beginning of my career, I was doing building acoustics and mechanical electrical acoustic design. I was deputy chair of the Next Generation Group at the British Aviation Group. To date, I'm part of the sustainability working group of the British Aviation Group. In terms of what I do in my work, I assist the coordination of wider environmental topics areas such as noise, carbon, air quality, and work to create noise and environmental strategies with particular focus, as I said, on aviation projects, which might include airport developments, airspace change, or research work. Among the projects I've been working on in my career, there is the Heathrow expansion, so the noise assessments with regard to the third runway at Heathrow expansion. I worked on the project until the beginning of 2020. There is Heathrow Airspace Modernization, the latest Gatwick Noise Action Plan that will be delivered by Gatwick this year. I worked as well for the European Commission Directorate General Environmental on a study on airport noise reduction, where I was assessing the noise management framework provided by European legislation across 63 airports in the European Union, and I'm working as well in creating the noise strategic plan for Fiumicino airports in Italy. As I said, I'm part of Noise Consultant. There is an independent firm specialized in environmental noise and vibration management and assessment. And Noise Consultants is part of a wider group that's called the Logica Group, which comprise air quality consultant and logical consultants. So together we are specialized in environmental assessment. That means air quality, climate change, noise, biodiversity, water management, natural capital, and as well socio-economics impacts. We also work together with various experts within the environmental and aviation industry, and as well within the academic world, in order to provide an holistic approach and a multidisciplinary integrated approach when we provide our assessments. So let's start now with just a briefing of what aircraft noise is. So the causes of aircraft noise can be from the engine, the jet engines, and the fans. And these are the main sources during the departures procedures of an aircraft. And as well, we got the airframe noise. There is the air, is the noise generated from the contact between the air and the airframe of the aircraft during landing operations. And this is a typical noise together with fan and turbines when an aircraft arrives at an airport. So these is acoustic factors, as together we other factors that we need to take into account when we consider aircraft noise. So the noise at source, aircraft noise, engine technology, as well flight procedures, and so the way the engines are used during the operations, whether if an engine is used at full thrust or reduced thrust can generate different level of noise. As well, we consider the distance between source and receiver. So if we increase the distance between source and receiver, we can minimize the noise, and this one can be achieved by the introduction of different procedures such as continuous descending approach, continuous coming operation, or steeper approach. All they meant to have a larger distance between noise and receiver. And as well, we need to consider the protection of the receiver through land use planning, so providing a sort of acoustic zoning where the planning authorities and local authorities knows, depending on the external noise, what kind of activities they can include within the different distances from the airport boundaries. And as well, noise insulation scheme try to mitigate the effects of noise to the population nearby the airports. So just mentioned the effect of noise. Let's see what they are. So we can consider the acoustic factors. They are just outlined, as well the impact of noise on the health, what in the European legislation are called harmful effects. As well, we want to understand what the likely significant effects when there is a change of airspace or a new development that is connected to the airport. And we need to consider supplementary metrics and non-acoustic factors they are important, as well as the acoustic factors, in order to better understand what is the situations around an airport. In terms of impact of noise on health, noise can have a significant and disruptive effect on everyday life, and there are many different effects and sources of noise, and the people can experience the noise in different ways. But research that's been undertaken so far have shown the noise can have an impact in terms of cardiovascular diseases, on sleep disturbance, on annoyance, on mental health, well-being, quality of life in general. And the response of the noise is by the human is extremely complex and varies between people, places, and they are influenced by many non-acoustic factors. I mentioned supplementary metrics and the non-acoustic factors. So it's important to understand the airport noise and aviation noise goes beyond the decibels, beyond the acoustic factors. Annoyance is not just a response function that can be used to calculate noise levels, but includes a range of non-acoustic factors that airports need to take into consideration when developing noise management strategy. Non-acoustic factors include feelings such as anger, fear, unsatisfactions, and principles such as trust, transparency, fairness, influence. They are all valued by communities. So it's important to listening to the communities, what are their concerns, and try to address them using practice and tools that now start becoming more and more spread around airports in order to address this kind of concern. So using community forums to gather opinions from the from the communities and involve them in the noise management process, as well as other practices such as noise envelope concept. So sharing the improvements in noise brought by, for example, technology improvements between the airports and as well the communities. And as well, there are other practices and tools such as land use planning and management and noise isolation scheme compensations that can be involved while developing a noise management strategy. It's important to combine, therefore, noise, populations, health effects in order to assess the performance of a strategic option, identify eventually what are the communities that are effective and the cost associated with noise impacts. So when developing a noise strategy and when we carry out a noise assessment, it's important to understand that a small change in noise at a higher level can have a higher impact even on a small sample of the population. As well, we can consider that a small change at a low level in a wider densely populated area can have the same effect in terms of cost of the society for this kind of changes brought by an airport development. So while we develop the noise management strategy for airports, we need to identify what are the problems and situations that can be improved. It's important to set what the so-called SMART objectives that are specific, measurable, achievable, realistic, and time-bound, and identify the noise measures in order to achieve these objectives. And within the aviation industry, these are identified through the so-called ICAO balance approach that tends to find the possible mitigation options by reducing the noise at source through the land use planning and management, through noise abatement operational procedures, and as a last resource, if none of these three pillars of the balance approach work, or they can identify a solution to achieve these objectives, operating restrictions that tend to limit the operativity of the airport. It's important to do, therefore, a cost-benefit or cost-effectiveness analysis to understand what are the implications in terms of cost that the airports can have in the introduction of these noise mitigation measures, and the effects in terms of health improvements or cost of the society. And through the process, it's always important to bring the stakeholders along and as well the local communities, so engage them throughout the entire process. So this is kind of what we consider for the noise and the noise management for an airport that involves, as we said, not just the acoustic factors, but as well non-acoustic factors and the interactions with the local communities. But it's as well important to understand that there are other environmental effects and environmental impacts that we need to consider along with the noise impacts in order to have a more holistic approach to deal with the environmental impacts. So we need, just to set a bit of the context, there's been an increase of the air traffic in the last 30 years, and there's been more and more concern about policymakers, traffic authorities, and policymakers of what's going on in terms of the environment, and a bit more thought about how it's possible to find solutions that can mitigate generally the environmental impacts. At European level, there have been set some targets. So there is some policy to by the European Commissions to achieve a zero pollution by 2050, and there are a lot of different policies as well to be net zero by 2050 that have been generated by the different member states and other countries around the world. And there are some interim targets to be met in order to show that in 2050 we can achieve these zero pollution targets. For example, the European Commission set targets by 2030 to minimize the effects of noise in terms of chronologically disturbed by transportation noise by 30%, and in terms of air pollution by reducing them of 55% compared to the previous years. But we are facing a kind of dilemma because air quality, carbon emissions, local emissions, they are all belongs to different physics spheres. So carbon emissions, for example, is one of the main contributors of environmental impacts, and especially at global level. But then we go environmental impacts such as noise and air quality that have an effect more on local level. They belong to different physics domains, so they're measured in different ways. The quantification of the overall effects, the overall environmental effects, is difficult because there's no a model that is able to describe at the same time CO2, air quality, and noise. And as well, there's no a single metrics that represents all the different metrics at the same time. So when we talk about interdependencies for aviation, environmental interdependencies, we can differentiate them in technological interdependencies. So these ones are the interactions between noise, CO2, and air pollutants. They are dependent on the engines, technologies, and the airframe. And as an example of these constraints, for example, if we want to reduce CO2 by incrementing the bypass ratio, and so have a better combustion of the fuel within the engine, it's possible to reduce the CO2, but the effect that you're going to have is an increment of NOx. At the same time, if you were trying to reduce the NOx, so by, for example, reducing the cruise altitude or reducing the bypass ratio, so doing the opposite of what I just described for reducing the CO2, of course, you would have an increment of CO2 and at the same time an increment in noise due to the reduction of the distance between source and receiver, because you would fly at a lower altitude, and at the same time, the way the engine works would generate more noise. And then we go operational interdependencies. They are the interaction of the different emissions. They are dependent on the airspace management and the aircraft operation. So, for example, in this image that is taken from one of the latest report that NATS produced on sustainability, you can see that a route from the runway in an airport flying away to any destination can fly in different geographic areas. So if you want to optimize CO2 emissions, we would try to have the shortest distance as possible from our airport to the distance that we want to get. But the risk is that we're going to overfly areas that are populated, so with residential dwellings underneath. At the same time, if you want to create a route that is optimized for noise, we'll try to avoid this densely populated area. But the effect is that we're going to have a longer route, and therefore more fuel is going to be used, and therefore more CO2 emissions, more CO2 will be emitted. So it's important to find a balance, a trade-off between the two. So last year, So last year, myself, my colleague David Da Vinci, and James Straw have wrote a paper that meant to quantify carbon in airspace noise management measures. And it was presented at Internoise 2022 in Glasgow. There is a conference on worldwide for noise consultants and research universities. And we were included in the sustainability topic. And we presented a methodology and a process to take into account the trade-off and the balance between carbon emissions and noise for airspace changes. So what we did is, therefore, to develop this process that on overall was able to identify what would be the benefits or the disadvantages of operational procedures based on airspace design under UK policy. These considerations were addressed through the monetization of harmful effects for noise impacts and the cost associated with carbon emissions. And the overall benefits and disadvantages were evaluated through what we call the environmental interdependencies matrix. We evaluated the single components, so different procedures, the aircraft would flight, and understanding how they differentiate by different aircraft. We understood the trade-offs, implications between these different procedures, and we used the information that we gathered to inform the designers of the airspace in order to find solutions that would work in terms of overall environmentally. For the noise monetizations, we have considered the effects in terms of annoyance, acute myocardial infarction, dementia, stroke, sleep disturbance, and other noise-related effects such as respite. And we use the government tool that is called, it used to be called WebTag, now it's just called TAG, that provides a cost-benefit analysis. While for carbon emissions, we carried out the monetization, taking into account the length of the track that compose the airspace and the associated fuel burn for aircraft type, and the cost were calculated through the governmental greenhouse gas emission values, which represent the monetary value that the society places on 1 ton of carbon dioxide equivalent. Once we had the monetization for the noise and for the carbon, we used these environmental interdependencies matrix. It's quite simple concept. So it's a visual representation of the cost associated with noise and carbon, and identifies 4 different quadrants. So one that would be good for noise and good for carbon, one that would be bad for noise but for carbon, and vice versa, and one that it would be bad for noise and bad for carbon. As well, it's possible to then identify the trade-off, so when the cost of noise could balance those ones for carbons and vice versa. And we can compare with a baseline scenarios and see how much we can change from the status quo. We then applied this methodology in a real case scenario. So we evaluate, as I said, the operational procedures that will form the airspace, and for each concept we generate a simulation of the model in terms of noise and carbon. The result of the noise model were interpolated with the data of the population, and then monetized through the government tool, the WebTag tool, to get a cost in terms of health impacts assessment generated by the noise. And then for the carbon, we used the track length, and for each track length we have calculated an average of fuel burn for each aircraft type, depending on the distance, we then calculated the fuel burn, and then we used the fuel burn as a proxy to calculate the carbon emissions that were monetized and then included in the environmental interdependencies matrix. In terms of noise, so what we have looked, for example, at different procedures and how the noise would vary geographically, and see how much change there is from one procedure and another one, and as well how different aircraft would perform the same procedures. And at the same time, we have looked at the carbon emissions and see if there was any difference between operating one procedure and another one, or between aircraft. What we found is that, for example, by comparison of a level flight at 6,000 feet compared to 90,000 feet, not 9,000 feet, for three different aircraft, 777, A320, and A320 of the new generations. The difference in noise were depending on the type of aircraft and have a very geographical effect. So it would be important to understand what there is on the ground in order to say to prefer one procedures versus another one. In terms of carbon, fuel burn differences associated with the two procedures were aircraft dependent. So comparing the fuel burn per nautical mile at 10,000 feet for 777, the leveling off was expected to be more fuel efficient than climbing straight at cruise level, while the opposite was for the other two aircraft. And this difference in operation for the A320 would give extra 70 nautical miles that could be used to then provide, for example, a more noise efficient route. So the evaluation of these operational procedures were used then to inform the design of the airspace, and the concept of the airspace were then modeled and monetized in order to provide a cost for noise and carbon. These costs then were visualized in our environmental interdependencies matrix. And what we found was that there were options that could provide noise benefits, but at the expense of a very high cost for carbon emissions. There were other options that would provide carbon benefits, worsening the noise conditions. And then there were other options that would provide the noise benefits and offsetting the carbon emissions. So it seems that could provide overall unacceptable environmental outcome for the airspace options. So these kind of assessments then was used to inform the airspace designers in their work and carry on with the airspace change project. And what we could do with these environmental matrix is as well to define acceptable environmental performance that takes into account the trade-offs between noise and carbon, but as well we could make these matrix three-dimensional and add air quality. So by monetizing the effects of air quality, we could find a common matrix or a common metric that can be used to describe noise, carbon, and air quality effects at the same time. And the ambition would be to have a multidimensional matrix that can provide as well not just environmental consideration, but also socioeconomics, can take into consideration socioeconomic factors, and we could therefore have a more holistic approach the assessment of an airspace change, or more generally, if we want to perform an assessment of a new development or a new airspace change. So that was it.
Thank you for that, Piero. Great presentation. We do have a few questions, so I'll just go straight into them. The first question, what is the max noise reduction that can be achieved with NI of a building because noise reaches through various routes?
It depends. So noise, as I said, it can be reduced in different ways. So it can be reduced at source, it can be reduced through the path, through the operations, and through noise insulation schemes. So if you're trying to reduce noise at source, probably is the most effective solutions. And we need to consider that since the last 30 years, noise has reduced a lot. If you're taking into account, for example, Heathrow, from the 70s to date, the noise contours are at around 57 dB, reduced by almost 8 times. And this is mainly due to the improvement in technology. But when this is not possible, then of course we need to try to reduce the noise in other ways. So making flying aircraft in different locations where there's no population, or if it's not possible to reduce the absolute noise, so we need to reduce the effects of the noise, and the noise insulation scheme can provide this kind of insulation. So by providing second double glazings, mechanical ventilation, we're able then to reduce noise levels within a dwelling to acceptable noise levels they are referenced by other standards.
Perfect, thank you. This one's quite a long one, but it's been a while. This is from Phil. So it's been a while since I've been involved with aircraft noise. However, I recall there were moves from NETS towards GPS-based navigation rather than preferred noise routes for departures, as it is a potential to increase capacity and reduce emissions. And the question is this still happening? And is there a view on how this will impact noise mapping and noise exposure?
Yeah, it depends. So there are now works to have what they call the PBN routes, so perform-based navigations, that tend to have aircraft like on rails, so like would be on rails, so following precise routes. So the effect with these, it would be, of course, a better management from operational, but there would be effects of concentrations. So it would be very good for people that would be overflown anymore. So you would have a reduction on the areas where to date you have the spreading of the routes, because then won't be overflown anymore. Of course, you would have concentration of those residents that would be overflown now more because of this new kind of way of flying. The way you could reduce the noise for these people is by implementing new procedures. So if you increase for example, the angle of approach, you would increase the distance between the noise and the receiver. But when this is not possible, then you need to act on the building itself, providing noise insulation. So you would be able to provide the double glazing, mechanical ventilation, in order to guarantee that the effects of noise within the dwelling are reduced and people won't experience harmful effects of noise.
Fantastic. Another question from Christopher. How can pollution by aircraft be reduced to net zero by 2030? Is it by carbon trading by airlines because synthetic jet fuel still produce combustion pollutants, and are EV aircrafts not an option?
So I'm not an expert of air quality, so my expertise would be it's noise, of course. So I'm not the best person to answer how air quality can be improved. Definitely, it's towards working towards an improvement in technology. All the efforts that the industry is now focusing is reducing CO2, reducing air quality, and perhaps there's a lot of talks about using a hydrogen aircraft rather than electrical, because you still need to produce electricity somehow. But if you think that in the last 20 years, a lot of the focus by manufacturers were around reducing noise more than the CO2 emissions. And noise was reduced because now we have, compared to aircraft of like 20 years ago, much quieter aircraft. The way it's going to work probably is going to be the same for air quality and CO2 through the improvement of technology. I don't know if electric flights will be an answer. Hydrogen, it could be different technologies can be used, but there is so much focus nowadays on CO2 and air quality that it seems that actually the improvements are more on that side, and actually there's less done on noise. And ICAO is the international organization that, for the civil aviation, is actually forecasting the noise. It would be one of the main pollutant and the effects on health after 2030, because air quality and CO2 will be reduced faster than noise due to this focus by the industry on these two pollutants, or anyway, these two topics more than noise nowadays.
And do you think because there is a focus on air quality and the CO2, that airlines and airports are quite resistant to making changes to reduce the noise pollution?
It's, in my opinion, it's more like a problem of focus. It's sometimes different experts tend to work in isolations, and rather to provide an holistic approach, they tend to focus on one aspect compared to another one. As I said before, manufacturing were focusing a lot on noise before, and now the shift is more on carbon. I was reading some industry articles where they were trying to optimize routes for carbon and air quality, but they were forgetting they were flying over densely populated areas. So where you had a gain on one side, you have a loss on the other one. That's why a key message it would be to work together to find the most optimal solution, in order to not forget the other pollutants or the other emissions, and trying to understand the trade-offs and find a balanced solution that would try to optimize different emissions. So one example is, sorry if I'm taking most of the time to answer this one, but one example we are using nowadays for airspace change is to work on altitude basis. So considering different effects depending on the altitude of the aircraft. So noise would be more important when aircraft flies between 0 and 4,000 feet. So giving more importance on around the altitude to noise, and then between 4,000 and 7,000 feet, or anyway to cruise level, giving more importance to carbon. So the way you would design some routes that needs to take into account this altitude approach, in order then to deliver a balance between the different emissions.
Fantastic. The last two questions are quite similar, so I'll just ask them both at the same time. At a major airport, can you realistically manage landing approach and takeoff patterns for different types of aircraft to optimize noise and CO2? Aren't they all drawn into a single airspace management plan? And kind of related to that is, what are the implications for air traffic control systems of a more complex departure and arrivals?
Okay, this one is more questions for the operational team. So I'm afraid I won't be able to answer. But generically, from my understanding, from what I know, because when we work on these airspace change projects, we are working with NATS, we are working with therefore airspace controllers, with designers, with the airports, is trying to understand what is your fleet mix and trying to optimize your airspace based on majority of the routes, but as well understanding what would be the consequences if you have some outliers that for some reasons they couldn't implement one particular operations. But this is more questions for the experts in that set on operational sides, and I'm afraid I cannot provide a precise.
Fantastic, thank you. It's really interesting to actually hear the kind of impact of the noise pollution. I think, like you say, there's always more conversations around about the CO2 and the air quality, so it's definitely good to see that different perspective. So that's it from us today, attendees. Thank you for logging in. I hope you found it beneficial and informative. If you are watching on the YouTube channel, please subscribe and hit the bell icon to get notifications. Our next webinar is taking place this Thursday, and it's on the Unlocking the Sustainable Blue Economy from Vision to Realization. And again, it's free to attend, so visit the IES website to register. And I just want to say thank you again to Piero, and thank you for everyone attending today. Thank you.
Thank you very much. Bye-bye.